Before I work through some of the remaining problems from section 3.15 I'd like to go over some definitions and how you can tell by looking at an equation if there's a horizontal asymptote. Now, I have some definitions here. These are in the class notes. A balanced rational function. I use the word balance to describe a rational function where the degree of the numerator equals the degree of the denominator. Now, the degree is simply the largest exponent. Look at the largest exponent in the numerator and the largest exponent in the denominator. If those are the same, we say it's a balanced rational function. The way you find the horizontal asymptote is by coming up with the equation y equals a over b. Now, a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Bottom-heavy functions are where the degree of the numerator is less than the degree of the denominator. The degree of the numerator is the largest exponent in the numerator. The degree of the denominator is the largest exponent in the denominator. If the degree in the numerator is smaller than the degree of the denominator, we call that a bottom-heavy function. All bottom-heavy functions have a horizontal asymptote, that is the equation y equals 0. We also have top-heavy rational functions. The top-heavy rational functions are where the degree of the numerator is actually greater than the degree of the denominator. Look for that largest exponent in the numerator. If that's greater than the largest exponent in the denominator, we say it's a top-heavy function. For all top-heavy functions, there is no horizontal asymptote. And then finally, if the degree of the numerator is exactly one more than the degree of the denominator, there is an oblique asymptote. And the way you find the equation of the oblique asymptote is by using synthetic division. And the part before the remainder is the equation of the oblique asymptote.